Hello, and welcome to 5 Minute Math. Today we are looking at lessons learned from the 6th grade 2023 STAAR test. My name is Aaron Daffern, creator of the 5 Minute Math videos. And what we're going to do is we are going to look at the readiness standards with which the state of Texas had less than 50% mastery on the 2023 STAAR test. We will look at each problem, how to solve it, but more importantly, why students struggled and what the instructional implications are. So we're going to start with 6.8b. Only 15% of the students got overall mastery. Now, when we're talking overall mastery, we're talking full credit. So this is a 2-point problem. And so only 15% of our students were able to get this correct. And this is number 25. And so when you're looking at number 25, you need to find, the two triangles, right? And then you also had the rectangle in the middle. These three fulfill the answer of having equal areas. And so students needed to use two different formulas, right? 1/2 base times height for both triangles. And then we also have the 1/2, just the regular base times height for the rectangle. But in order to solve this right, you would need to go ahead and solve for all five and see which three have the exact same area. Now you see that 50% of our students were able to get at least two correct, right? So this is all three, and you get 2 points, 15%, and this is two correct, and you get 50% partial credit. That means that they got, uh, you know, 1 point out of the two total possible. No credit, they either got one correct or zero correct. So, what made this challenging and what are the instructional implications? Well, whenever you have multi-select, it really makes it a little bit more difficult because you have that certainty that's no longer there. Multi-select really just makes you understand the answer itself. So many of our strategies involve looking at answer choices and eliminating incorrect answer choices. So that type of answer strategy just doesn't work here. And as strange as it might seem, the fact that the correct answers included both triangles and a rectangle, students might not know that a triangle can have the same shape, the same area, but different shape of, the exact same quantity. So the fact that you've got a triangle and a rectangle having the exact same area might be a little bit mind-blowing for some of these kids because they're different shapes. And then the two different formulas that I mentioned, right? They had to keep that straight. The 1/2 base times height for the triangle, the base times height for the rectangle. So what does this mean for us? How can we as educators get better? Well, we need to have them practice finding multiple shapes, rectangles, squares, and sometimes we've done that, but rectangles, squares, parallelograms, triangles, trapezoids that result in the same answer. That's going to be a little bit of work on our part to find those shapes that have the same ultimate area, but we just need our students to understand that different shapes can actually have the same area depending on their sides and their proportions. And then have them do some of that work, right? So have them manipulate shape dimensions just to get a little bit more flexible with area, right? So give them a rectangle, have them find the area, and then say, what could you change the width to in order to make the area 15 square centimeters? Or what could you change the length to have, you know, 12 square centimeters? Or you have a rectangle, give them a height, a base and a width. We've got the base, we've got the height right here, we've got a triangle, right? Make them not equal. There's my height, there's my base. And say, what would I have to change the height on the triangle to in order to make it the exact same as that rectangle? Have them play with the numbers, and that will just get them a little bit more comfortable with this type of problem. So next we had 6.12d. This was only 20% overall mastery. This was an inline choice here. And so we had to find two things, right? We had to find the mode, right? And as always, mode is kind of a difficult one. Kids typically have no problem with range, and honestly, we do so much work with median, they understand it. They sometimes have difficulty finding it, especially if there's an even number. But it's this mode we don't do much of because it's seemingly the simplest, right? But they had to find the mode, which was the soccer, and then they had to find the percentage of the campers uh, that chose basketball, and that was 25%. Now that took a little bit more work because you had to find the total altogether, and then make that into a fraction, right? So that's 40. That basketball is going to be 10 over 40. Now, once you got to that, most of our students were able to say, oh, that's 1/4. Oh, that's a benchmark fraction, 25%. So we only had 20% of our students get both of these correct, right? 2 points. 50% got one correct, and we don't know which one. So what does this mean for us? Well, students had to know the definition of mode and apply it, and this, I think, might have been the more difficult part, finding the percentage of the campers who chose basketball. They had to first find the total, and that's what we call a hidden number. Now, it didn't take much to get the 10 plus 15 plus 5 plus 10 to make 40, but sometimes students struggle when all the numbers are not explicitly provided for them. And then inline choice made it a little bit more difficult. I mean, inline choice is kind of like multiple choice, but you had to go back to the data multiple times for different purposes. And so sometimes students might be used to only going to the data once looking for mode, or only go into the data once looking for percentage. So students need to, again, just practice every time they see a data set. They need to find the median, mode, and range just so they get it, drilled into their brains, because those terms are never going to be defined on the reference materials for them. And then we just need extra practice finding the percentage of the total for a single section, right? Like how many of the kids there chose soccer, or how many of the kids there chose basketball, which is, what they're asking. Or you can have them find multiple selections, right? So what percentage of the kids, chose basketball and soccer, right? So do they know how to find basketball and soccer by adding those two and still, making it a fraction with the total as its denominator? But just different variations of finding that percentage until they get that procedure down. So our next one was 30.5% overall mastery. We had graphing 6.11a. This one actually had two different problems. And as you can see, we didn't do too well on either of them, right? Look at number 14. First, we had to know what quadrant 3 was, right? So students hopefully were able to quickly visualize, right, these four quadrants. I always remember it with the letter C because it goes in that order right there. And you need to find a horizontal. Okay, so here we need to know that it goes side to side. Hopefully that's a term that the students are familiar with. And then 2.5 units. So if I'm going 2.5 units, I could technically go here, but that would still put me in quadrant 4. So 1, 2, but here's the problem. Here's my answer right there, and it's on a half x value. And look at the scale factor. The scale factor is 1, so it's not very intuitive that you can actually put it on that scale factor. This is just a 1-point problem, so they either got it right or they didn't get it right, and only 23% of our students actually got that right. And then this one over here, number 22, right? Which one best represents point Z? Point Z is not there. Now we have to graph it, right? So it's -3.5, +3, so it's going to be right there. But once again, scale factor is 1. But look at that x value. It's -3.5. And then we just had to count how far away, which one is, 3.5 units away. And the answer there is that R. And only 38% of our students were able to get that right. So what made this so difficult? And what does that mean for us? Once again, it's this scale factor of 1, yet graphing the item required on both, right? This first one was negative, 0.5, but the other one was -3.5. So just graphing on halves when the scale factor is 1 can be a little bit challenging for some of our students. We had to know where quadrant 3 was, and if that was something that was kind of skipped over or they weren't sure, then there were a few different options that could have been correct. That quadrant 3 was the deciding factor there. Right, point Z on number 22, it wasn't plotted. Now they gave you the coordinates, but you had to plot it yourself, and if you made a mistake plotting it, then that's going to be difficult. And unless students are using the graph feature on there, they're not going to want to draw, a coordinate grid on a piece of paper, because remember this is taken on the test, so they need to use that graphing tool so they can kind of plot that point Z. Points were mixed numbers, not integers. And then number 22, right? So that was the second one. The answer distribution of this one really indicates guessing. So we just had students not really sure what to do with that one. And that might have been because it was an online test and they needed to use that graphing tool in order to plot it because it's just too difficult to visually kind of keep that up there. So we can help our students with the graphing tool. Right, we need to use a mnemonic to memorize the 4 quadrants, right? I use the letter C. That's 1, 2, 3, 4, simply because that's the order in which you go through the quadrants when you're drawing the letter C. We need to have them practice plotting half points. That's going to be very important because if it's all just integers, then they might get confused. And then we can easily just have them practice. Just here's a coordinate grid. First, find this point. And then find me a point that is 4 units distant horizontally that's in quadrant 1. Okay, so they're going to have to go over here. Find a point that is 5.5 units vertically distant in quadrant 3. So you have to go down here and just give them those opportunities to find distance from a point because both of these problems wanted them to find distance from a point. All right, so next we had 6.4b. This was 31% overall mastery. We are solving predictions and comparison of real-world problems involving ratios and rates. And we didn't really do well on either one of them, right? So number 13, we only had 35% correct. And we had to figure out the ratio of large dogs to small dogs is 4 to 3. But look, we had how many dogs in the show were small dogs? So that we're not really using the 4 to 3. What we're using is small dogs over how many dogs at the show. So that's the total. Okay. So if I've got large to small is 4 to 3, then I can say 3 out of every 7 dogs, since I've got the 4 to 3 ratio, are going to be small. And they already told me that there's 63 dogs at the show, right? So I can either do cross multiplication or I can just use facts. All right, so 7 times 9, 3 times 9, there we go, 27. And then I've got this ratio right here. And so what I need to do is I need to figure out, okay, so it's 2 to 3. They kind of give it to you right here. And take a look at this one, number 32. 47% weren't able to get any of them correct. So that's interesting. And what are we doing here with this, with these two? Well, if we apply this ratio right here, we will see that, 24 to 36, right? 2 to 3, 24 to 36. And then I've got my 108, and that's going to be, right, 72. So we can just use cross multiplication. We can use facts, right? If I multiply this by 12, and then if I triple this, I'll get this over here. All right, so what made this so difficult, and how can we help our students? So the most chosen response for number 13, okay, so that was the first one, involved just dividing 63 by 3, right? So let's take a look back at number 13. So take a look. The most chosen response here The correct answer was D, 27, right? But the most chosen response was B, and that had 38% of our students, right? 38%, that's more than this 35%. So this is 38%. And all they did was they just divided 63 by 3. So that's 63 over 3. So they didn't set up the ratio. They knew there were some small dogs and they knew they can divide, and the answer's right there. So some students just had difficulty, honestly, setting up the ratio. And then the correct answer, right, used a hidden total, right? You had to figure out that it was that 3 over the 7. 7 was not provided for them, right? Number 32, that was the second one. The drag and drop always eliminates assurance that you would typically get from multiple choice. And even though the ratio was kind of set up for you 2 to 3, that it still provided some problems. And yeah, it was set up exactly. It wasn't like inverted. Sometimes they'll give you a ratio of 2 to 3, but then the columns are set up in the inverse order. Okay. So what we need to do is just continually give our students opportunities to practice, right? First, like number 13, um, we were given a ratio and the whole, right? And we needed to find a part. And on number 32, we need to find a part if just given the ratio, right? We were just given the ratio of 2 to 3. So there's different ways to find ratios. We just need to have our students become very comfortable when they see a problem like this, right? Like this, okay, it's called out exactly on number 13. So we should see that that should be a ratio. And then right here as well. So when we see that, we should automatically think something like this, right? We should think using some type of ratio like this, proportion, to go ahead and solve. And then we need to use tables like we see on number 32. That's going to help them find multiple missing parts, not just one. All right, for 6.5b, we only had 31.5% mastery, so we didn't do much better on this one right here. And we are solving real world problems. And then look, finding the whole given a part in the percent, finding the part given a whole in percent, and finding the percent given the part in the whole. So this is kind of a beefy standard. Number 8 only had 12%, and I can probably tell you exactly why. We don't know the real reason, because it's a it's one of these equation editors, so we can't analyze incorrect answers. They don't provide those for us. But look, it's the not, right? How many of our kids do you think simply multiplied, 850 times 32, 0.32, and they got 272? I bet you that's so many answers. But that's how many had an annual pass, right? So if you figure that out, you could then have to divide or subtract that from 850, because that's how many had an annual pass. How many did not have an annual pass? There's your 578. Or you could have done this. You could have said, well, if 32 had an annual pass, right, then that means 68% did not have an annual pass. That'll get you straight to that 578. But that extra step really messed up our students. Take a look at that, 12%. Now, we did quite a bit better on number 30, right? This is literally 29/50. You can divide up. You can double it, right, to get to 100ths, and you can say, oh, look at that, 58 100ths. So we did a little bit better on number 30. I think it was number 8 that really messed us up, because they had us find the complement. So what made it difficult? What could we do? Well, it was the equation editor. So that also made it more difficult, because at least you didn't have multiple choice, though, if this were multiple choice, 272 would definitely be an answer. So that wouldn't have helped us too much as well. We needed to find the complement, or the probability of something not happening. So we need to have students practice, finding the probability of something happening, or the percentage of something happening, and then the complement, the percentage of what's not included in that solution set. And then finding the part, given the whole in percent requires multiple steps, right? So we had to, if we wanted to find the part given the whole in the percent, right, we needed to change the percent into a decimal, multiply it, or sometimes even subtract it if we didn't find the complement. Whereas, number 30 was a little bit more straightforward. All right. So for any problem, have students find both the part percent and the complement. Get them used to just what happens when it says not. Okay, that's a really great way to double check your work because obviously, right, for it to work, this if this is the complement, right, this is the 578, well, that plus the 272, it should equal back to that 850. So it's a nice way to double check your work is getting them used to finding the part and then the complement. And then have them show, multiple methods of solving the problem, right? So finding the problem, um, converting the fraction to the percent, like number 30, there's multiple ways to do it. We don't want them to just get used to one method or one algorithm. We need to find creative ways to get them to solve the problem, um, involving equivalent fractions, dividing up, multiplying by decimal, more than just one way, so they have that flexibility. All right, 6.7a, we did 33% overall mastery, so not super fantastic on this one either. Only one problem tested for this particular standard order of operations, but man, this thing was beefy. So take a look at this. First, right, we would need to take care of inside the parentheses, we'd have to take care of the exponent, right? So now you got 16 minus 10, okay? Then within the parentheses, you have to collapse that to 16 minus 10 is 6. Now we can bring everything else around. Okay, so now we need to simplify that. That's 25. And then we need to simplify that minus 36 minus 3. But now I'm subtracting, and I'm going to end up negatives, right? That's going to be kind of confusing, but that does simplify down to negative 14. But that's just a lot of steps for students. And if you mess one up, then obviously the whole thing is, going to be messed up. So we included parentheses. We included two different exponents. We had multiplication and subtraction of the order of operations. That's a lot. A lot of times you might only get three, sometimes even two operations. And then within the parentheses, you had to do something first, right? You had to simplify the exponent before subtracting. And that still assumes that our students know what exponents means. How many of our students think, that 4 squared equals 8, right? Or that 5 squared equals 10. I bet you some of our students are still messing up because they think that means times 2 rather than times itself. So that's something that we can help our students, verify. And the answer distribution really suggests guessing. Students probably did their best. They didn't find an answer and they just ended up guessing. So we can provide order of operations that include 4 or more operations, right? So I had parentheses, exponents, multiplication, and subtraction. We probably need to provide our own to make them beefier because what we're getting out of our math textbooks might not be enough. And one of the problems that we see is when we're writing down the PEMDAS like this, right? We think that we have to multiply before we divide. We think we have to add before we subtract, and that's not true. So we need to make sure we have problems where we divide before we multiply, we subtract before we add, just so they show that multiplication and division are equal operations, and you can divide first. Same with subtract. And then this one didn't use it, but how about brackets, right? How about we do this, like 3 squared plus 4, and then we can do 2 minus, and then we could do plus 8, right? Have them practice, okay, parentheses and brackets. Which one do you do first? They need practice with both. All right, 6.6c, 38% overall mastery. There's only one problem. We only get 38%, right? So we just need to show, right, a relationship that says y equals 3x, right? So that's a multiplicative relationship, and that's going to be in this one right here, right? So what this is showing, students might not have the vocabulary for it yet, but this is direct variation, right? And so we just needed to find which one showed that relationship. The answer here was C, and it seemed pretty straightforward, right? We would hope that kids would be able to, just create a little table, right? If x is 0, y is 0, if x is 1, y is 3, and that's 2, and that's 6. And that's basically all we needed. That's the only one that works when y equals 3x, because we even could have said, hey, look, we're just going to multiply by 3. That's the rule. So what made this difficult, and what can we do for our students? Well, the most chosen incorrect answer had the x and y values inverted. So if you could look back here, it's this right here, right? So they had just the x and y values inverted. And so that means that students were trying. What they might not have been able to do is just say y equals 3x. How do we substitute in and turn it into a table? That might have been the tricky part, not necessarily plotting it, of just taking a basic equation, y equals 3x, substituting in values for x to get a y value, and turning it into a table. And then students should have plotted points of their own choosing, and they had to recognize that it was a multiplicative relationship. So those three things made it difficult. Have students, first off, plot an additive and a multiplicative relationship on the same coordinate grid, just to differentiate between the two. So they hopefully should see how steep that multiplicative relationship is and how shallow that additive relationship is in regards to the slope. And then students should be able to explain the similarities and differences of options A and C. So they should look for, oh yeah, they are kind of the same graph except the x and y values. If we can get them to see the difference between these answer choices, that's going to help them not make that error when they are presented with it. And we also just need to provide them opportunities of maybe even without the graph, even just get rid of the graphs and just give them something as simple as, here's a new one, y equals 4x. Can you give me 4 points that you would use to plot? Can they turn this into an XY table? And just have them do 0, 1, 2, 3 just to begin with. That might not work for every single graph, but you're probably going to be pretty safe with that. Can they put those points, right, into an XY table? If they can do that, then they can graph. 6.7D, we had 38% overall mastery here, and we needed to find an equivalent expression. This was using the distributive property. What made this difficult is, look at this. That 7 is on the backside. When we typically see examples, right, we'll see something like this. We'll see the 7, the multiplier, up on the front side, but they had it on the back. It's still the distributive property. You still need to multiply that 7 by both terms, right? So that's 7 times 3p plus 7 times 2. And then you can obviously simplify that 7 and the 3. That's going to be 21p, and 7 and 2 is going to be 14. So my answer here is D, but students should have recognized the distributive property, and that is a term they should use. They're going to be using it for the rest of their mathematical career in middle school and high school, so they should call it out when they see it, the distributive property. And typically, right, like I said, that 7 would be on the front side. That multiplier is typically in front of the multiplicand, but it wasn't in this case. And the most chosen answer, B, right here, only multiplied the constants, right? So this is, I'm just going to multiply the 2 times 7. So students might have not really known that you can multiply a 7 and a 3p, right? You can multiply the 3 and the 7 and the two numbers, and you could just leave the p alone. And that was probably a sticking point for some students because they only thought you can multiply like terms, but you do have a like term right there in that 3. So what can we do to help our students? Name the distributive property, give them that academic vocabulary, make sure they can use that term, they know what it means, they can explain it. Give them opportunity to draw examples, like an area model multiplication. That's one of the first ways we learn about it in the 4th grade, is the area model for multiplication, but just verbal explanations of the distributive property. And then checking their work with substitution, right? If we would have simply gone back here and said, okay, let's make p equals, sometimes 0 doesn't work, but we can, try 1. P equals 1, well, substitute in 1 right there. So that's going to be 3 times 1 plus 2 times 7. So that's going to be 5 times 7. That's going to be 35. What happens if I make P1 right here? 3 times 1 plus 14. That's 17. So we easily could have checked our work and said, oh, that's not going to work. Simply because I substituted. That is a good way to double check your work here. All right, 6.3D. We actually had 2 different problems here. And as you could tell, look, we really didn't have a problem in number 26, right? We got 67%, even though it was a little bit tricky because the correct answer here was D, none of these. The reason it was D, none of these, right, is because you had positive 3 minus 5. The answer was negative 2, and that wasn't there, but that really didn't mess them up. The problem was this one, right? We needed to use our order of operations, right? So we needed to go ahead and divide this. So this would be 35 minus, this comes first. So now we've got a negative 22 multiplied by 2. So 35 minus, now I've got a negative 44. And then if I even get to that point, I need to know, what does it mean when you subtract a negative? That means you add, right? So our answer here is 79. So we had to subtract a negative, right? That was just, can be a very conceptually confusing thing. The correct solution required dividing before subtracting. Obviously, we're definitely not going left to right on this. We have to use the order of operations, and this was the first one. And I bet you a lot of students didn't necessarily do that. They probably just jumped straight into this 35 minus 110. And the parentheses had no operation. Sometimes that confuses kids when they see the parentheses, right? It was the negative 110. They just did that because they wanted to separate the 35 minus, because it looks kind of weird if you do this 35 minus negative 110, that parentheses is just used as a separator. And the answer distribution suggests guessing, and the correct answer was actually the least chosen. So everyone was guessing all over the place here. And 22% is actually the lowest. And students just really had no clue what to do. We were guessing all over the place here, didn't know how to set this up, didn't know how to solve it. So what can we do to help? All right. So we need to give students multiple representations for subtracting a negative. In case their conceptual error was the fact that they didn't know that subtracting a negative turned out to be positive, right? We can give them number lines. We can use algebra tiles. We need to get them to understand that 2 negatives make a positive. And then we need to have students, probably just to see the difference, have them solve the problem correctly, like we did up there, right? That's 79. Have them solve it left to right, just to see that there's different answers, and you can't just go left to right. You don't want to necessarily reinforce the incorrect solution, but maybe this is something you work out, because you want to show them, look, if you go left to right, you're probably going to find this answer there, but it's not going to be correct. But sometimes they just have to see the difference to know that you need to follow the order of operations. All right, 6.3E, we are looking at overall mastery at 48%. So definitely doing a little bit better here. We're multiplying, dividing positive rational numbers fluently. What we needed to do here on number 4 was, we had 350 per pound, and we need to multiply that by, 1.5. Well, you had a decimal and you had a fraction, so probably would be good to go ahead and make them both into decimals, right? So 350 times 1.7, 1.5, that's going to get you 5.25. We did pretty good on that. I mean, 59% is kind of low, but that's pretty good. Our issue here was number 28, right? We had 18 boxes, And we needed to, here's the thing, we needed to conceptually see that we needed to divide it by 2/3, right? So we should hopefully know that dividing by numbers is the same as multiplying by the reciprocal, right? And our answer here is going to be, for number 28, the answer is A, that 27, right? It ended up, being 54 over 2. And you saw we only got 37%. So it was that 28 that really messes up on this particular standard. And we didn't really struggle, like I said, with the first one. We had to recognize this as dividing by a fraction. And the most chosen incorrect answer for B had students multiplying 32%. So let's go back and look. Right, 37% got this one. But almost as many students got this one. And what this would be, that's just, 18 times 2/3, right? That's 36/3. That's 12. So how do we recognize division problems in problem situations? Well, a representation would have been very helpful to find the correct operation, right? So let's say I've got 18 boxes. And so I'm just going to draw some boxes here. Let's draw 3 boxes, and let's just assume I draw, 6 rows of that to make your 18. Each student uses 2/3 of a box. Okay, so I'm just going to draw these in 2/3, right? So I'm going to say these two are student 1, these 2/3 are student 2, these 2/3 are student 3, right? And so look, even out of these 2 boxes, right, if I go on and I'd have a little bit left over. I should notice here that out of 3 boxes, or out of 2 boxes, I used 3 students. 3 students can get enough out of 2 boxes. Well, if I've got a total of 18 boxes, right, that means there's going to be 9 sets of 2. So if there's 9 sets of 2, right, that's going to get me 18, the full 18 boxes, right? And each of these sets of 2 actually ended up being 3 kids. So there's your 9 times 3, that's 27. So you could have used a visual representation to see, you know what, I'm actually dividing by 2/3, and I'm actually getting 3 kids out of 2 boxes. So I just need to, find that pattern and multiply. That's one way to help them find the correct representation. Have them use an inverse operation to check their work. And then if they can explain it verbally, so many kids can just multiply or divide a number. And if they see an answer choice, they think that's it. But have them explain their work. So they try to explain to you why this works or why this doesn't work. Finally, 6.4G. 49.5%. And as you can tell, we did fine on number 3, right? 8 out of 25. We need to find that percentage. 8 out of 25. There's a few different ways to do it. To me, I'm always wanting to get my denominators into 10, 100, 1,000, right? So we did good, relatively speaking, on number 3. Our issue here was number 33, 5%. So many students just chose A. 5% is 5 over 100. So you simplify, you're going to get 1/20th. Your answer here is D. We didn't struggle with number 3. Here's the problem with the second one, right? 5%, if you go back and look, the number 5 is not in the correct answer. And for some reason, some students think, oh, I need to have a 5 in the answer. So they think either A or B. The answer, 5%, involves a 1 and a 20, does not involve the digit 5, and that's fine. The most chosen answer for 33 was that simple decimal placement, right? It's 0.05% is what, or 0.05 would be that 5%, and they just had a decimal misplacement. They just had 0.5. And so they were close, probably thought this was an easy problem. And when you think it's that easy, it's probably not. So we need to have students practice changing from a percent to a fraction in a variety of ways, right? So can you change like 5%? I didn't necessarily do it this way, but can you go straight from that into a decimal? right? 0.05, and then change that into a fraction and then simplify, right? Or what I did was this, 5% into the 500ths. You can go straight into that as well, knowing that each percent is out of 100. And then have them explain verbally. See, this would have been a nice check for some of these kids. We probably know that 5% is really, really low, but we should know that 0.5 is half, and that's 50%. And even if they were to explain their answer, oh, that doesn't make any sense because 0.5, that's half of it because that's a benchmark fraction. So they should know they should be looking for a very small fraction. That means we have a very large denominator, and the only one that's even close to that is our correct answer, D.